Hello everyone. So now let's see the extension of the previous lecture. So last time we started with the basics of the complex number. Now this lecture we'll try to study the argument of complex number. We already have introduced the what are the argument and the modulus of complex number. Here we will try to focus on the principal argument. So we know that if any complex number, if theta is the argument. So what is theta? It is the angle with respect to the positive direction of x-axis in anti-clockwise sense. So any complex number is here. So the argument of z is theta. Argument of z is theta. So there is a general argument, there is a principal argument. So what is the general argument? As we discussed in the previous lecture, the general argument is basically of z is basically the 2n pi plus theta. Okay, where n is any integer. Okay, so here for different values of n we will get different theta. No? So you can observe here that if suppose complex number is here, so this is theta is possible, again 2 pi theta is possible, again 4 pi plus theta is possible, and similarly in the clockwise sense also we'll get. So general argument means the argument of z is infinite values, theta, 2 pi plus theta, 4 pi plus theta, and so on. But we are more interested in complex number in the principal argument. That is more important. Principal argument. So what is the principal argument? Principal argument basically we sometimes denote by the capital A. So principal argument is theta. In this case, this theta lies from open bracket pi to close bracket pi. Okay. So here it is from 0 to pi for first quadrant and the second quadrant, and 0 to minus pi for fourth quadrant and the third quadrant. So clearly for first quadrant we have the 0 to pi by 2, and the second quadrant we have the pi by 2 to pi, and for the third quadrant we have a minus. We measure in a clockwise sense, that's why it's a negative value. So minus pi by 2 to minus pi, and obviously fourth quadrant is 0 to minus pi by 2. Okay, so here first quadrant, this one we measure like this, and the second quadrant again we measure like this, the third quadrant we measure in a clockwise sense, and the fourth quadrant again we measure in the clockwise sense. Okay, this is how we measure the principal argument. So principal argument means we only get the value, we are able to get the values once. We are not doing a periodic argument. Okay, so but that to cover all the quadrant, first, second, third, fourth. Okay, how to find all this? For different quadrant this value changes. So how do we find? So if the complex number lies in any quadrant, let's say lies first or any quadrant, so we define something alpha. What is alpha? So tan alpha is basically, let's say z is equal to a plus ib. So this distance is b and this distance is a. So tan alpha is b upon a. So alpha we can say is tan inverse positive value of ba. So whether b is negative or positive, but the mod b by is always positive, and this alpha is lies in from 0 to pi by 2. Okay, so we'll see in each quadrant how do they behave. So let's talk first about the first quadrant. So in the first quadrant means somewhere here, first quadrant, a plus ib. So theta, argument of z is theta, but since tan alpha is b by a, both b and a are positive, so I will write b by a. So alpha is tan inverse b by a. Okay, so this is also if you want to find the tan alpha, b by a. So in this case basically this is the b, this is the a, so theta is also alpha. And how to find alpha? Tan inverse b by a. So in case of first quadrant, the principal argument nothing but the tan inverse b by a. The positive b and a both are positive because they lie in the first quadrant. Now what happened in the second quadrant? Let's say second quadrant is more interesting. So first step is, if any, let's say here z is equal to a plus ib, the principal argument will be theta. So the principal argument is theta, that is the angle with respect to the positive direction of x-axis in an anti-clockwise sense. Okay, this is the principal argument in the for the case of second quadrant. Now our first step is finding this value, tan alpha mod b by a. Got it? Since b is here positive but a is negative, so overall b by a modulus is negative. So if I say what is alpha here? Alpha here is mod b by a is a value from 0 to pi by 2. So essentially what is alpha here? Alpha here is this value, theta. Got it? Because 0 to pi by 2 value. So what is the theta here? Theta is, sorry, this is alpha. This is alpha. Okay, this is alpha. So what is theta here? Theta here is pi minus alpha. Got it? Theta is here pi minus alpha. So I can say that the principal argument of z is pi minus alpha, where alpha is given by tan inverse positive value of b by a. Got it? Now what happened if they lies in the third quadrant? That is quite interesting. Third quadrant. So if any before this third quadrant, let's take one basic example, then you have an idea. Let's say we have to find the minus 2 plus 3i. We have to find the argument of principal argument of minus 2 plus 3i. So obviously this lies in the second quadrant. So minus 2 plus 3i. So this, the principal argument will be this value. And what is the, so first step is we would find alpha. So what is alpha? So tan alpha is positive value of 3 upon minus 2 positive. So what is alpha here? Alpha here is tan inverse 3 by 2. And alpha, since 3 and 2 are positive, so tan inverse 3 by 2 is the value in the first quadrant, 0 to pi by 2. So essentially this is the alpha. Okay. So what is the theta here? Theta is nothing but the argument of z, that is pi minus alpha, where alpha is given by tan inverse 3 by 2. Okay. Now let's take one more example. Let's say z is equal to minus 1 plus root 3i. So I have to find the principal argument of this one, this minus 1 plus root 3i. So obviously this lies in the second quadrant, minus 1 plus root 3i. So first step is to find tan alpha. What is tan alpha? The positive value of this one. So that is root 3. So what is alpha? Alpha is tan inverse root 3. And since this value, see, this tan alpha is positive, means alpha will be lying either in the first quadrant or in the third quadrant, but we'll always take alpha the value of the first quadrant. So this should be the value in the first quadrant, 0 to pi by 2. So what is alpha here? See, alpha is tan inverse root 3, so that is pi by 3. Okay, so in this case, this theta is the principal argument. And what is alpha here? Alpha here is this particular value, this is alpha, that is pi by 3. So what is the argument of complex number z, that is minus 1 plus root 3i, is theta, that is nothing but pi minus pi by 3. Agree? Because this alpha, I can write one more line. So pi minus alpha, but alpha is pi by 3, so pi minus pi by 3, that is 2 pi by 3. So I can say the argument of this particular complex number minus 1 plus root 3i is 2 pi by 3. Okay, now let's talk about what happening in the second quadrant. So second quadrant means it lies somewhere here. So the principal argument will, in case of principal argument, the argument is fine, but this is not the principal argument, because this value of angle going beyond the pi. But we said that the principal argument theta should lies from minus pi by 2 pi, so it is not going beyond pi. But if we talk about this angle, this is going beyond pi, so this is not the principal argument. In fact, the principal argument will go in the clockwise sense. Okay, so here also let's say z is equal to a plus ib, so we'll find a tan alpha is equal to b upon a positive value, or alpha is, so b upon a positive value means this distance, basically this distance is b and this distance is a, and this is not a valid thing, so I will delete it part. So b by a, so obviously this is the alpha, this is alpha here, so tan alpha is b by a, or that is tan inverse b by a. So what is the theta? That is the principal argument. We can say that the theta is pi minus alpha. This is pi minus alpha, okay, but since we are measuring in the clockwise sense, so it will be minus pi minus alpha. Got it? So we can say that in third quadrant, argument of z is theta, that is pi minus alpha is the magnitude, but since we are measuring in the clockwise sense, hence we'll put the minus here. Okay, let's take one example. Let's say z is equal to minus root 3 minus I. So again it lies in the third quadrant. So what is tan alpha here? Tan alpha is minus 1 minus root 3 modulus. So tan alpha is 1 upon root 3. So alpha is tan inverse 1 by root 3, that means pi by 6. Okay, so what is this pi by 6? Pi by 6 is this value. This is pi by 6. But what is the principal argument? Principal argument is this one. Okay, so the principal argument means the angle which is measured with respect to the positive direction of x-axis in a clockwise sense. So magnitude wise, what is this value? Pi minus pi by 6. Magnitude wise, this value is pi by minus pi by 6. But since we are measuring in a clockwise sense, we'll put the minus here. We'll put the minus here. So again, in case of this theta, so this is the theta is the argument of z, that is pi minus pi by 6 with minus sign, because we are measuring in a clockwise sense. So this is minus 5 pi by 6 is the answer. Okay. Okay, so now let's talk about what is happening in the fourth quadrant. Fourth quadrant. So fourth quadrant, let's say any complex number lies in the fourth quadrant. Z is equal to a plus ib. Obviously in this case a is positive but b is negative. So what is tan alpha here? Our first step is to find tan alpha. Tan alpha is b by a positive values. So again here same, this is the value is b, this is value a, so b by a positive value will be alpha here, tan alpha. Got it? And what is the principal argument of this z? Or this theta is, this is also theta, principal argument. Okay, so theta is minus alpha. Why? Because we are measuring in a clockwise sense, that's why, and always measured with respect to the positive direction of x-axis. Okay, so that's why theta is minus alpha. Magnitude is alpha, but since we are measuring in a clockwise sense, that's why the value is written with minus sign. Okay, for example, let's say we have to find the minus 1, let's say plus 1 minus I. We have to find the principal argument of 1 minus I. So again this is somewhere here. So what is alpha here? Tan alpha is minus 1 upon 1 mod, that is 1. So alpha is pi by 4. So alpha is pi by 4. But what about the argument of z? That is theta, that is angle this theta. Okay, since we are moving in a clockwise sense, so this is nothing but pi by 4 is the magnitude. Pi by 4 is the magnitude, but since we are moving in a clockwise sense, we'll put a minus pi by 4. Okay. So essentially we can say that, summarize, we can say that z is equal to a plus ib. Okay, where alpha is tan inverse positive value of b and positive value of a. B may be negative, a may be negative, but we'll start considering with alpha is tan inverse b by a. Obviously here this alpha belongs to 0 to pi by 2. Okay, this is the 0 can be a close bracket, but obviously pi by 2 will be open bracket. So alpha is the first quadrant, acute angle. Now depending on which quadrant the complex number lies. If the complex number lies in the first quadrant, so this is the theta is alpha, straight up. The principal argument is alpha. But if they lies in the third quadrant, so in the case theta is pi minus alpha. Why? Because we discussed that the alpha lies in this one. acute angle. Whereas in case of the third quadrant, so third quadrant, this is the theta, and obviously this is the alpha. So theta is pi minus alpha, but since we are measuring in a clockwise sense, so I will put it here minus pi minus alpha. Similarly, if it is fourth quadrant, so fourth quadrant, obviously the alpha is here, and this is also the principal argument. So theta is equals to minus alpha. Why? Because this theta is measured in a clockwise sense. Okay, let's take some example. So if I say what is the argument of value 3, so where does 3 lies? 3 lies somewhere here. So this complex number is this one. So what is the argument here? 0. Okay, because this is argument is, what is the argument? That is the angle which is measuring with respect to the positive direction of x-axis in a anti-clockwise. But since it is just lying on the x-axis, that's why, or they are parallel to x-axis, that's why this is the argument of this particular number 3 is 0. Similarly, if I say what is the argument of minus 2, so minus 2 somewhere here lies here. Okay, minus 2. So this is this is the complex number. This. So what is the argument? Argument is this one. Okay, pi. Angle is always measured with respect to the positive direction of x-axis in a anti-clockwise sense. If we move the clockwise, it will be negative. If you move anti-clockwise, the value is positive. So minus 2 is pi. By the way, it's a pi and minus pi is also possible, both. But you should know that this theta, the principal argument, is from open bracket pi to the close bracket, so open bracket minus pi to the close bracket pi, minus pi to pi. So we'll always take pi, not the minus pi. Got it? Similarly, if I ask you what is the argument of I means it will lie somewhere here. So argument of I is pi by 2. So this is pi by 2. If I ask you what is the argument of minus 2i, so minus 2i lies somewhere here. It's a minus 2i. Okay, this is the complex number, and since we are asking the principal argument, we can't move like this. We have to move in a clockwise sense. Okay, so that value is, magnitude is pi by 2, but since we in a clockwise sense, we use minus pi by 2. The magnitude of this is pi by 2, but since we are moving in a clockwise sense, that is a minus pi by 2. So this answer is minus pi by 2. Okay, now few of the interesting easy question. What is the argument of pi? Argument of pi is 0. Why argument of pi is 0? Because pi is a real number. It will lie somewhere here. So its argument is 0. But if I say what is the argument of minus pi by 2? Again, pi by 2 is a real number. Minus pi by 2 is also a real number. Only since it is moving in a negative x-axis side. So minus pi by 2 is a real number. And that's why since the argument angle is taken with respect to positive direction of x-axis, so we will measure from here and then we go here. So that is pi. Okay. So important thing is we should know that the argument. Okay, argument of purely real number is 0 or pi. So purely real number means the complex, it will either lie in the real line axis. So this is either positive or negative. If it lies on this side, this one, then the principal argument is 0. Whereas if they lies in the negative direction, so that means its argument is theta is pi. So this is how we have the argument of a real number is there. So argument of real number is either 0 or pi. If lies on the positive direction of x-axis, then obviously its principal argument is 0, and if it lies in the negative x-axis or negative real axis, then the principal argument is pi. Okay, so you should understand that this is positive and this is the negative values, negative real number. Okay, now if I talk about the argument of purely imaginary number, argument of purely imaginary number. So that means either they will lie in the positive y-axis, in this case the argument is pi by 2, or they may lie in the negative x-axis, then the argument is minus pi by 2. So again, in case of this one, the argument is plus pi by 2 or minus pi by 2. Plus pi by 2 for the positive imaginary value, imaginary part. The imaginary part is positive, we use pi by 2, and this is when the imaginary part is negative. Okay, imaginary part is negative, then we use the argument as minus pi by 2. So essentially we should know that the z is equals to a plus ib. It has the modulus is a square plus b square, and it has the argument of z. Oh, let's have a principal argument. I use the capital A. Argument of z is theta. Now this may be alpha for first quadrant. You understand? That means, let's say any complex number, let's say this is z. So this is the argument of, this is the modulus of z, and this is the principal argument. Okay, so alpha, we know that what is alpha. Alpha is tan inverse b by a, positive value. So in case of first quadrant, this is alpha. In second quadrant, we have the pi minus alpha in second quadrant, and this is pi minus alpha with negative sign, because why it is negative? Because these are measured in a clockwise sense. So basically in this case, this is the thing. In the second quadrant, we have again measuring anti-clockwise, where in third quadrant we are measuring in a clockwise sense. That's why it is pi minus alpha and then minus sign. And the fourth quadrant, it will be, value is minus alpha. Got it? Minus alpha. Why? Because this is the thing, so it is measuring in a clockwise, and that why is the minus alpha. Okay, and what is alpha? Alpha is the acute angle. That's why you find tan inverse b by a. Okay, so let's discuss one important things, the forms of a complex number. We have the different forms of complex number. We discuss different forms of complex number. One of the standard form we already know, z is equal to a plus ib is the standard form. We already know. Now there is something called trigonometric form. Okay, we'll try to see how it is related. Trigonometric form. Okay, trigonometric form. Now observe here that any complex number, let's say z, is equal to a plus ib, and this is the principal argument, and obviously this mod z is the modulus. So this is b and this is a. So what is b? B is mod z sin theta, and a is mod z cos theta. So I can say z is equals to a plus ib. What is a? A is equal to mod z cos theta and mod z sin theta bi. So what we get? Mod z common, I get cos theta plus I sin theta. Okay, so in trigonometric form they are represented like this: mod z cos theta plus I sin theta. So what is this one? So in any complex number, this is the modulus, and this theta is the, we can use general argument or principal argument. I'm just saying the argument, that's all. Okay, then so this is, we have done the standard form, trigonometric form, and so we have the standard form a plus ib, the trigonometric form in terms of cos theta and sin theta. Then we have third, we can say it's a Euler form. There is something called Euler form. You can see the Euler form, that is very interesting. Euler form. So Euler form, any complex number is written as mod z we know that the cos theta plus I sin theta, obviously theta is the argument of z. We can also write like this, mod z e to the power I theta. That is the Euler form, and this is a very powerful tool. Because of this Euler form only, the complex number are used widely, and this simplify the complex problem. Okay, so from here we can know that e to the power I theta is equals to cos theta plus I sin theta. This is also very interesting result. We'll derive maybe this class not possible. Next lecture we'll derive why e to the power I theta is cos theta plus I sin theta. Okay. So basically this I am emphasizing, mod z is equal to mod z e to the power I theta is called the Euler formula, Euler form. Okay. Because of the e is a Euler number. Since e is involved, hence it is called the Euler form. So in a summary of forms of complex number, we can summarize that z is equal to a plus I. This is a conventional form or this is standard form. We can say it's a conventional or standard form. Okay. Similarly, z is equals to mod z e to the power I theta. This is the Euler form. Euler was a scientist. Then there is something called mod z cos theta plus I sin theta. This is the trigonometric form. And if it is like this, sometime mod z and theta, this is called the polar form. Okay, why polar form? Because if any number in a plane P has any point in a complex, any point in a Cartesian plane, similar to the concept in the Argand plane also. If any point in a Cartesian plane, if you want to reach that point, either you move a distance here and then b distance here. That's why it is called a comma b. Or you find the distance a square plus b square, that is r, and then theta. R is nothing but modulus z. So if you want to reach at point P, you from the positive direction of x-axis, you incline yourself toward theta and move the distance r, then you can reach the point P. Okay, so that's why this is called all theta or polar form. R is the distance from the origin to the point P. Same way modulus z is also distance from origin O to point P. So this is the polar form. And obviously well known, this is a comma b. This is the called standard form. It's a ordered pair form. Ordered pair form. Okay. So this polar form we see in detail. So you can see that in case of Cartesian form, okay, we have any point P here, we have to move the distance x and we have to move the distance y, then we can reach the point P. Hence the point P is written as x comma y. Whereas the polar form, so if we want to reach the point P, so we have to, from the x-axis, our direction towards the theta, and then move a distance r. So the action theta and move distance r. That's why polar form is written as r comma theta. Okay. See, very interesting. This z is equals to r e to the power I theta. Obviously r is the modulus z and theta is equal to is the principal. It can be any argument, not as principal. I just say argument. Okay, argument of the complex number z. And this is the very, very powerful form of the complex number, due to which many calculations become simple. Okay, let's take one example and understand. So let's say any z is equals to 1 plus I to the power 10. So z is 1 plus I to the power 10, and the question is write in Euler form. First is write in Euler form, and the second question is write in standard form or the conventional form. Standard form means x plus I waveform. Suppose in this particular question we have to write in the Euler form and also we write in the standard form. So how do we do? see, first if you want to write in the standard form directly, one process is you just use the binomial theorem and then you expand it and then solve it and take the real part and the imaginary part. Okay, so this so one method is very lengthy method is this one. If we have any complex, any 1 plus I to the power t, using the binomial theorem we can have some part plus I to power some dirty part. Okay, it will take lots of time in calculation, so using binomial theorem. So rather than binomial theorem, if we use the Euler form, so Euler form means 1 plus I written as a r e to the power I theta. What is r here? 1 plus 1 root, so r is root 2. And what is theta here? Theta here 1 plus I lies in the first quadrant, so theta is alpha. So theta is alpha and alpha is tan inverse I, and I has coefficient 1 and 1 is 1, that is 1 upon 1, that is pi by 4. Okay, so 1 plus I is 1 e to the power I pi by 4. So what is the value of 1 plus I to the power 10? That is e to the power pi by 4 to the power 10, e to the power I pi by 2. Okay, so 1 plus I to the power 10 is converted to Euler form like this. Now if I ask you to write, obviously it's Euler form, r is 1 and the argument is 5 pi by 2. But if I ask you the convert into the standard, solve into standard form or convert into standard form, so it's easy. We have e to the power I 5 pi by 2, that means 1 cos of 5 pi by 2 plus I of sine 5 pi by 2. Okay, so cos 5 pi by 2 means cos of 3, we can have a 5 pi by, anyway 5 pi by 2 will be 0 because pi by 2 multiple of pi by 2. So this is 0 plus I sine 5 by 2. So sine 2 pi plus pi by 2. So this will turn out to be sine of 2 pi pi by 2 1, 0 plus I sine 2 pi plus pi by 2 will be sine of pi by 2. Okay, so sine of pi by 2 is 1. So this is 0 plus I. Got it. So ultimately some mistake. Okay. Here r is root 2. So here I have to make the root 2, here root 2, here root 2. So here again to the power of 10. Okay, power of 10. So root 2 to the power of 10. So we'll get here something 2 to the power 5. So again 2 to the power 5 and then 2 to the power 5, 2 to the power 5. So 2 to the power 5i or 32i. Okay, so essentially 1 plus I to the power 10 is 32i. So this is a complex number with power is 10, whereas this is a purely imaginary number. Okay, but using the Euler method it become easy to solve and very quick. If you want to use some other method, then or let's say binomial method, then you have to use the binomial theorem to simplify and then solve. Got it? Let's take one more example. Let's say simplify z is equal to minus 1 plus root 3i by 2 to the power 5. You have to simplify or write in the standard form, a plus ib form. So we start with minus 1 root 3i by 2. This is, we can write like r e to the power I theta. So what is r here? So r in this case is minus 1 by 2 square plus root 3 by 2 whole square root. That is 1 by 4 plus 3 by 4 root. So 4 by 4 is 1. What about theta? Theta is, it lies in the, which quadrant? It lies in the minus 1 plus root 3. Oh, lies in the third quadrant. So third quadrant, obviously, what is alpha here? So first we will find the value of alpha. So alpha is tan inverse positive value root 3 by 2 divided minus 2 minus 1. So it will be tan inverse root 3. That is nothing but pi by 3. So alpha is pi by 3. So this is pi by 3. But the argument is angle with respect to the positive direction of x. That is the argument. That is pi minus pi by 3. that is the 2 pi by 3. So that is 2 pi by 3. So we have a minus 1 plus root 3 I by 2 is equals to r is 1 e to the power I 2 pi by 3. But we need power 5. No? Our question is to solve to the power 5. So what we'll do? Minus 1 plus root 3 I by 2 to the power 5. It is power I 2 pi by 3 to the power 5. That is e to the power I 10 pi by 3. No? It's other form. Now if you want to solve, convert into the standard form a plus ib form. So we write first into trigonometry, that is cos of 10 pi by 3 plus I of sine of 10 pi by 3. That is what is this one? Cos 10 pi by 3. That is cos of 10 pi means 3 pi plus pi by 3 plus I sine 3 pi plus pi by 3. That is cos 3 pi plus pi by 3. It goes in the 3 pi plus pi by 3. That goes in the third quadrant. So it's a minus cos pi by 3. And again the sine goes in the third quadrant. So again minus sine pi by 3. So minus cos pi by 3 is pi by 3 is minus half, and this is minus root 3 by 2i. So this particular dirty things using the Euler form can easily be converted into the standard form. This is nothing but a minus half minus root 3 by 2i. Okay. So okay. So I am ending the class here. Next time we will see the derivation. We will see the derivation of this particular Euler form. So we'll next time we'll derive y e to the power I theta is cos theta plus I sin theta. We'll do the derivation of this part, and then we'll move towards the solving some of the problem.